we're going to be taking a look at how we've enhanced the user-defined links capability we first introduced in Integrity 9.3 release. This feature helps our customers to document and navigate user-defined IPAM relationships. The UDL architecture has been updated in Integrity 9.4. Now customers have the ability to utilize both APIs and newly the Address Manager to create, update and delete user-defined link types, manage which entities are linked together under those types, and perform the full lifecycle of operations for user-defined links. The full lifecycle operations of user-defined links can now be managed via the Address Manager for the first time. The management of user-defined links is supported by a dedicated section called User-Defined Link Types under the Data Management section in the Admin tab. In our first Demo 1, we're going to be creating a new user-defined link type to support dual stacking, that is, the linking together of IPv4 infrastructure to IPv6 infrastructure. We'll create a new user-defined link called dual stack in the Address Manager. We'll link together an IPv4 address and IPv6 address using this relationship. We'll navigate this relationship in the Address Manager, and then we'll remove one of the links to show some lifecycle operations. Our first action is to define a new user-defined link type for our dual stack relationship. New relationships can be defined by selecting the Admin menu and using the option User-Defined Link Types under Data Management. We give the link type a name of dual stack and set the display name to the same. We're using the new optional description field to define what this relationship is being used for. We then define what object types can be the source. In our case, we're defining IPv4 addresses and networks as a source, and then defining what the destination can be. And again, in our case, this will be IPv6 address and network. Clicking upon Add will update the Address Manager with our new dual stack UDL type. It's added to the list of defined UDL types with its description field shown, and we can see the source and destination types too. We can add a new link between a source and destination object type by clicking upon the dual stack type definition. As we're doing this from the Admin tab, we'll need to select both the source and destination objects, but we start by adding an optional description to document what this linkage is actually for. In the demo, this is a link between an IPv4 address and IPv6 address being used on an iMac machine. The link source is the known IPv4 address of the iMac, and the link destination is set to the known IPv6 address. We can now see this specific link under the dual stack type, showing the description, the source and destination IP addresses. We will now navigate away from the Admin tab by selecting the IP space menu and traverse down to the network of the source IP address for this iMac. We'll navigate down to the network 192.168.1.0 and browse down the table of addresses to our .70 address, which was the source. We can see the relationship to the IPv6 address is shown in the table, and we can navigate by clicking upon the address itself to reach the destination address. We can click back upon the destination of this link and return to the IPv4 object too. In our link type, we also defined that the IPv4 network and IPv6 networks could be linked together, so we navigate back up the hierarchy to get to the Details tab of an IPv4 network, which will be our source object. We're going to add a new link, but this time we're adding the link from within the Details pane of the source object. So we'll only need to select the IPv6 network, which will be the destination. We'll again add an optional description to document what this link is actually being used for. We then select that the destination of this link will be an IPv6 network. We need to do this as we had both IPv6 addresses and networks as possible destinations. We select the destination IPv6 network from the drop-down. We can see that our new link has been created by browsing down the Details pane to the User-Defined Links section. If we navigate back up the IP space hierarchy to the IPv4 block, which holds this IPv4 network, we can see that the dual stack relationship we just defined is shown in the table of networks, indicating that the source IPv4 network has a destination IPv6 network. We'll now navigate back to the Admin tab, which provides our administrators with an overview of all the links under a specific type. We should see both the IPv4 and IPv6 address link and the newly added IPv4 network to IPv6 network in our table of dual stack relationships. We'll delete our link between the IPv4 and IPv6 networks to show a little of the life cycle, including the warning message that's shown. In Demo 2, we'll model out another customer use case to document a NAT relationship. There are many types of network address translation, but we'll model a one-to-many NAT. We'll start again by defining a new NAT UDL type between IPv4 addresses and an IPv4 network. We'll link together some integrity objects using our NAT relationship, and then we'll navigate through the IP space to show this NAT. Same as the process we followed in Demo 1, we first need to add a new user-defined link type for our NAT relationship. We do this again via the Address Manager's Admin tab and selecting the user-defined link option. We enter the link type name, its display name, and enter a description. As we're modelling a simple one-to-many NAT, we select an IPv4 address as the source and an IPv4 network as the destination. You can see here our new NAT UDL type displayed alongside the dual stack UDL type we added in Demo 1. By clicking into the NAT type, we can add a new link between our source IPv4 address and the destination IPv4 network. We can see in the Admin tab that our new link has been created, and moving over to the IP space, we can traverse the hierarchy down to our source IP address and then follow the link to the destination IPv4 network by clicking upon it. This takes us into the destination network view of addresses. If we select the details pane of this destination network and browse down to the user-defined links panel, we can see that the link back from this network to the source IP address can be followed. Now ideally, you want to show on the IP space block view of networks that there is a link from our destination IPv4 network to the source IPv4 address used for our NAT relationship. Currently this isn't shown, so we need to select the Customize Table option and add the NAT UDL to the list of displayed columns. By carrying out this action, we can now on our table view of networks see that this specific network has a NAT and it's linked to a specific IPv4 address. Our third demo will highlight some enhancements made to the APIs in relation to user-defined links, and these are based on customer feedback. We'll show how the new description field can be used when defining link types, how descriptions can be added when linking entities together, and finally a new API call, getLinkedEntities by UDL, which can be passed a link type name to return all of the entities linked together under this specific UDL type. When creating a new UDL type via the API service, we make a call against the add-user-defined link. This API is passed a JSON payload to define the link type parameters, and new in Integrity 9.4 is the optional description field in the JSON. The description field is up to 512 characters in length, so it can support human-readable descriptions, or it can be used to insert machine-readable data into the field for automation purposes. Likewise, the LinkedEntities API call, used for defining which objects are linked under a specific UDL type definition, has also been enhanced in Integrity 9.4. We've added the same ability to pass in an optional description field. Again, this field supports human and machine-readable data of up to 512 characters. An API call to getLinkedEntities by UDL now supports the ability to list all of the objects which have been linked under a specific UDL type. It will show a list of all the object IDs and the descriptions when passed a target UDL type. Optionally, this API, it supports passing the source or destination entity ID, which will therefore just return the payload for this UDL type used on those objects. As we've surfaced additional context in the IPAM for users to view and navigate, this in turn increases the resilience of their critical infrastructure. What was obscure before can now be made apparent to reduce risk. And this feature helps our customers embrace the hybrid cloud. The UDL feature can be used to document the relationship between on-premises infrastructure and applications and those homed in the cloud.